Have you ever wondered why a small rope can hold a massive boat without unraveling? Well, most people tie a knot around the post to make sure it doesn't unravel. But actually, if you just wrap a rope around a post two or three times, the rope will not unravel, even with massive amounts of force applied. Why is this? Well, the answer is similar to this example using two books. If you interweave the pages of two books and try to separate them by pulling from the bindings, you cannot pull them apart, no matter how hard you try. The TV show Mythbusters went to the extreme and tested if two interwoven phone books could be pulled apart by two tanks. Ultimately, the tanks were unable to separate the books by the pages. Instead, the binding of one book was torn off while the pages stayed together. So, how is it possible for interwoven pages of paper to withstand so much force? Well, as you may have guessed, it is due to friction. But this case has something special going on. First of all, books are very tightly bound. The paper near the binding is very tight, while the paper towards the outside is looser. This stacks the pages in a bowed shape. When the user grabs the books by the binding, they make the paper near the binding even tighter and create more bowing of the pages. Here's the equation for friction. The static coefficient of friction for printer paper is around 0.45 and is constant. When the user grabs the books by their bindings, they create more bowing of the pages, which dramatically increases the force required to overcome static friction. Then, when the user tries to pull the books apart, they increase the normal force and are met with a proportional friction force. If you simplify the situation to just two pages of paper, you can see that pulling will cause the pages to stick together. Then, when you multiply this by hundreds of papers, you get an incredible amount of friction. Even two tanks driving in opposite directions cannot apply a force beyond the maximum static friction force that the books are capable of. The situation with the rope is very similar. When the user pulls on the rope wrapped around a post, it does not unravel because the force you apply is making the rope wrap around the post even tighter, which increases the frictional capabilities of the rope. Thanks for watching. I hope that made sense. If it did, the next time you want to impress someone with your knowledge of physics, just ask them to take out a couple of books.